Hi guys, so what we thought would be useful for you is if we made a getting started video for connecting up the rail voltages of an op-amp, or an operational amplifier that you're going to use in this practical. With the rail voltages, I mean this value over here, this plus 12 volt and this minus 12 volt. Now, you're going to have to do that using the DC power supply. Of course, this power essentially feeds into the operational amplifier and allows us to generate an amplified version of the inputs. All right, so how am I going to do that? Using the equipment in the lab. Okay, you have at your disposal one device over here. This is called, if you don't know it by now, the DC power supply. It will generate this plus 12 volt and also the negative 12 volt. How am I going to measure now what I generate? You can see it on the screen, but that's not really accurate, right? We told you a much better device is this one, which is called the oscilloscope. If I connect cable here to the input channel and I apply it to an output channel, so let's just take one of the channels for now, forget about that one. Let's focus on using this channel over here. Okay, let me just organize this. I'm going to, okay, so now I'm going to connect that output channel, should give me a reading of about 12 volts to this channel. So let's do that. Okay, there's the plus and there's the ground, the neutral. Okay, so, and as I'm expecting on the screen, I'm getting a value of about 12 volts. So how can I see that? So let me just go back here. Typically, what you will see when you connect it up is not something that's very nice. You might see a little scribble signal here or some noise or something, and a button that works very well is the auto set button. So there it is, that little guy over there. You press auto set and the oscilloscope sets itself in using the correct divisions and everything. And then you can see there's my yellow line with an average value of 12 volt. Okay. Something that's really important here, when you press back, make sure that over there, DC coupling is set to DC. If it is something else, for example AC, you will see a noise-like signal that might look like that. And we don't want that, okay? So to sort that out, you go undo auto set, and you set your coupling to DC. And then you press the auto set button again, and then you would have the signal that I want. So in this case, my plus 12 volt. Okay, there we go. Now, something that I know you guys will do is you're gonna say, all right, I need to generate now minus 12 volt. So that's quick. Let's put up another channel, 12 volt, and all I'm going to do is I'm going to connect the negative lead to the positive one and the positive lead to the negative one to generate minus 12 volt. And you know what? If you do that, if I ask my assistant to please help with that, if you do that, you will in fact see negative 12 volt. Like that, which we can read on the oscilloscope. But why isn't that correct? Okay, so that isn't correct because these two ground points, that and that reference is now set at two different references, which we don't want. If you look at essentially what's going on here, we want to connect the reference to the same one called the common ground. Okay, so how on earth are we going to get that right now using this DC power supply? Simple way in which to do this is I'm going to ask my assistant to do the connection over here. We need to take the reference point of one of the grounds of the channel, of the DC channels, and feed that into the ground of, or the neutral point of the other channel. So thereby essentially connecting those two reference points, forming a common ground. Okay? So now what I will have over here, if I just trace this cable back, look at it. This one goes over here, right? I've got my alligator clippers over here, which I'm going to connect. And this one, these points are all together. That is now my common ground. this lead over here, that channel coming from the plus over there. This should be my plus 12 volt, and we can verify that again using our oscilloscope. Let's check. I'm going to connect the negative lead of the neutral point of the oscilloscope to my common ground. Okay, and let's see what's on the screen. Plus 12 volt. Perfect. Okay, now let's check the other channel, the negative 12 volt that we've generated. Okay, and there I have my negative 12 volt. So, just to recap, here I have connected a cable that essentially bridges these 2 points. You're going to have a lot of cables, so please try and keep it tidy. You have these cables connected like that. Okay, those points. That forms your neutral point. You tap off one of them, and that is your ground connection, your common ground. The negative terminal over there, this one is now the minus 12 volt, and this one over here, that would be your positive 12 volt. Okay, so essentially now we have created a circuit that looks like that. This common ground, if we start looking at the practical, we need to connect that up now to the operational amplifier. And for the inverting case, this will go to pin 3. Okay, and I'm going to leave the rest of the connections for you guys to figure out. All right, thanks. Bye.